So in last session, we discussed about how to create transactions, nested transactions, save points, and all. So in this session, let's continue from there. Let's continue discussing about transactions a little bit, and then concurrency models and the properties of transactions and the logs, how the logs will be helpful. Okay, now let's start with. We discussed about transactions. We can write any kind of transact SQL statement in a transaction. There are a couple of statements which can be used in transactions. So the set is like consists of alter databases. So this statement is not supposed to write in transactions, and I can say like the TSQL statement which cannot be used in transactions. So alter databases or drop database, or you have restore keyword and update statistics. So there are a couple of other things like this, like drop full text and alter full text index and so on. Alter full text index and drop full text index and so on. We have a couple of things like this, and you just need to keep in mind that it's not possible to write all the TSQL statements in the transactions. So this is about transactions, and let's jump into the concurrency. Concurrency. What is meant by concurrency, and what are the different types of it? And let's discuss how to avoid these concurrency problems. Let's say I have a resource here. Let's take an example, TV. You know TV, right? I mean, people, if this guy wants to see one channel and this guy at the same time wants to see another channel, that is concurrency, right? When two resources are trying to access the same available data. So in the same way, in database concepts, if you see this is your data, and this guy wants to access it, and this guy wants to access it, and some other guy wants to access it. That means, in short, many applications or several user applications tries to read and write the same data the same time is called as concurrency. So this is a big problem in SQL Server or in any database programming language. Why? Because when both the resources or multiple resources are trying to access the same data, then it will lead to deadlocks, right? So to avoid this, we can follow some properties or some procedures. Before going to that, first let's see how many types of concurrency models are available in SQL Server DBMS. So database engine supports two types of concurrence models. So the first one is pessimistic. Oh, I have to take the pen here. Fine. Pessimistic, and the second one is optimistic. So these two are very famous English words, right? Words from the dictionary. So people frequently use this. Pessimistic concurrency model. What is this pessimistic concurrency model? So what it do is it will use logs to block access to data that is used by another process. For example, let's say I have a data, and this is trying to be, two resources are trying to access this. So in this pessimistic model, what the first user will do is this guy will apply a lock saying that the other resource cannot access it until it releases the lock. So it is safe. This guy can only access it only when the lock is removed. So in pessimistic, it treats that there may be chance of conflicts and there may be chances for having a deadlock, so it applies locking as safe side, and then it will start reading or modifying the data. And the second guy will be available and waiting for its turn to come until it comes. It will be waiting for the access to the data. This model is called pessimistic concurrency model. In short, this one uses logs to block access to the data that is used by another process at the same time. Now, let's see what is meant by optimistic concurrency model. Optimistic concurrency model, it lives on assumptions. It purely depends on assumptions that a transaction or the other resource which is modifying the data in the same time will not lead, I'm extremely sorry. It leaves with the assumption that no other transaction will access the data that is being accessed by another transaction. That means, let's say, if this guy is accessing data and this transaction treats that no other transaction will have a, will try to access the same data. It treats that, it leaves with the assumption that is called optimistic concurrency model. So if you see the difference between pessimistic and optimistic, pessimistic will be always on safe side. It treats that there may be chances of deadlocks and it apply lock to secure the data, the data that it is reading by the particular transaction. But optimistic, it won't treat that, it treats and it leaves an assumption saying that no other resource will try to access the same data that is being updated or modified or read by this particular guy. So that is why it won't apply any logs to secure the data that is being used by particular transaction. Is it clear between these two? So if you see the differences between these two, for example, the first one, pessimistic, it will not make the data available to the end users, the second user. That's the problem with the pessimistic. But the optimistic, it will make the data available for the second one, third one, or the fourth one. But the problem with the optimistic is chances of deadlocks are very high, whereas the advantage of pessimistic is it won't lead to deadlocks. So this is the basic knowledge about pessimistic and optimistic concurrency models, and we need this information when we discuss about locking. When we are going to discuss about applying locks and so on, then you may get a question why we need to apply the locks. This is just because the concurrency models. So if the concurrency model is pessimistic, that means it treats that there may be chance to get a deadlock, so it applies the locks. For optimistic, it won't take care of the locks, or it won't worry about the lock. Now let's jump back. I mean, we got good enough knowledge on concurrency models. Now let's jump back to the transactions. I told you transactions have some properties. In short, we call it as acid properties. So what is meant by acid properties? Acid properties, in acid, A stands for atomicity, C stands for consistency, I stands for isolation, and D stands for durability. So in short, it is pretty famous as the word acid. So acid properties, transactions have the following properties, that acid, A stands for atomicity, C stands for consistency, I stands for isolation, and D stands for durability. What is meant by each property? If any particular transaction meets all these properties, then we call it as a perfect transaction. So everything should be fine with every transaction that we define. So to make a perfect transaction, you need to know what is meant by atomicity, consistency, isolation, and durability. First, let's talk about the atomicity. So atomicity talks about having all the queries, all the transactional statements in the transaction as a single atomic unit. So in short, either full or null. Either all the queries should be submitted, or all the modifications should be submitted, or none of the modification should be submitted to the database. That is called as atomicity. Atomicity means a unit, a atomic unit of work, and all the queries that are present in the transaction should be treated as one atomic unit. So let's take a simple example. I have a bank account, and I transferred some amount from my account to XYZ account, who is having account with the same bank. Let's assume the amount, what will be the query for it? Begin transaction, deduct from my account, right, and add to XYZ account. So the functionality will be like this: end transaction, sorry, commit transaction, right? So if I have queries like this, these are dummy queries. Don't say that these are not correct queries. I'm giving you an example here. So when I transfer amount from my account to another account, it will deduct the amount from my account and it will add the amount to the other guy's account. Let's assume if these two queries are not treated as one atomic unit, then this atomicity fails. So what is meant by treating as one atomic unit? Either full or null. If this query is successful and this is failure, then it should not submit the first changes also. So that is called atomicity. So if this is successful and this is a failure, and what has to be happen? Everything should be rolled back. So the case should be either submit everything, or either everything successful or nothing should be successful, nothing should be submitted, everything should be rolled back. So in short, either full or null. Imagine it deducted amount from my account. Let's say I transferred 1 lakh rupees and it deducted from my account and it is not added to the other account. There was some query problem here and it failed at this particular query, the second one. Then if it commits the transaction, then it's a big mistake, right? There will be some mismatch in the figures. The amount will not exist. 1 lakh rupees will be missing from my account. So that is why the atomicity is in picture. It says that commit all the changes, or if there is any failure, then revert back all the changes. So this is called atomicity of transaction. Now let's talk about consistency. What is meant by consistency? It's just like a consistent, a person, a player, or anyone should be consistent. In the same way, a transaction should be consistent, in the sense that the data that is present before the transaction should be in consistent state, and after the transaction the data should be in consistent state. Let's take the same example. Okay, I'm transferring amount from one account to another account. Before transferring, if my account is having a balance of 2 lakh rupees and I transferred 1 lakh using this query, and this guy's account XYZ was having only 1 lakh, or let's say 50,000 rupees. This is my account and this is XYZ's account. Okay, once I transfer the amount and if it is successful, then this guy will become 1 lakh and this guy should become 1.5 lakh. So this is called consistency. Earlier the data was consistent, it was having 2 lakhs, it's a consistent data, and 50,000 is fine. And after the transaction is completed, then also the sum should be same. If 1 lakh plus 1.5 lakhs is equal to 2.5 lakhs, similar to the starting the data that is present at the start of the transaction. So before the start of the transaction, when the data is in consistent state, after the transaction it should be in consistent state. So this concept is called as consistency in transactions. So in short, the best definition for this one is data should be in a consistent state when the transaction starts and when it ends. So there should not be any missing data. If I say I transfer 100 rupees and if only 50 rupees reach the destination, that is not consistent data, right? So The data should be consistent once the transaction is complete, at the start of the transaction and also at the end of the transaction. Now let's see the third one, isolation. It's pretty straightforward one. Isolation means you are isolated, you are simple, you are single. So when two transactions are running, and let's say begin transaction, this is one transaction that is running and another transaction that is running and another transaction that is running and another transaction. So isolation will make sure that the intermediate state of a particular transaction is invisible to the other transaction. That means if it is going through some changes to the data, this will not be visible to the other guys. For example, if this guy is having some account or some amount at the start of this transaction, and if it is in the middle, if the transaction is still going on, this guy cannot see the changes that are applied to this transaction using queries. Let's say the first query. These changes will not be visible until it commits the last transaction and until it commits the transaction. So when the transaction is in the process, then the other transactions will not able to see the changes that are being made by the transaction that is in process. So we call it as isolated. This is isolated until it is finished, and this will be isolated. Every transaction should be isolated when it is in process. So this property we call it as isolation property in transaction. So how it looks like, even though if you run 5 to 10 transactions in at a time, what will happen is first it will wait until it finishes. So, and then it will start and it will go for it, and then it will go for it, and then it will go for it. It looks like it is serialized. It can't see what's happening inside, and until it is finished, it has to wait. So we use isolation methods to separate these two things. How the transaction should be executed, we will use, to specify the same, we use isolation methods in transactions. Now, let's see the durability. Durability is one of the most important properties of transactions. Durability, after transaction is successfully completed, then the changes to the data persist, and by mistake, if it is not successfully completed, then everything should be undone. That is what this durability talks about. So for example, let's say I'm executing a transaction. If everything goes fine, what will happen? It will commit the transaction. Or if in the middle, due to some problem, the SQL server crashes, or if it restarted, then what will happen? It is neither committed nor rolled back. So that's a wrong situation, that the data will be inconsistent. So what this durability will make sure is durability, there will be a transaction log where the state of each and every transaction will be stored. Okay. So what this durability will do is make sure is once the system is restarted or once the SQL server is restarted, it will go and check the status of each and every transaction that was stopped in the middle. And for each and every transaction, it will find out what is the state of it, whether it can continue from there or it has to be rolled back. If it has to be rolled back, then we call it as undo. Or if it can be continued, then we call it as redo. So this is what durability will make sure. Even the system or SQL server restarts after crashing in the middle, then this durability will make sure that it will either redo or undo the transaction. So let me take an example for this. I'll go here. Let me take a pen. So I have a transaction, let's assume this guy, and I have so many statements. Assume these are SQL statements, but I can't write SQL statements now, so it is a time taking one. There are some statements, SQL statements in the transaction. So everything that is happening in the transaction, every transaction will be written to a file called transaction log. So transaction log will be there. Everything will be written to this transaction log, like, okay, this particular transaction started and first query executed, second query executed, third query executed, and so on. Everything will be written to the transaction log. Now, while executing this statement, if the system crashed or SQL Server restarted, then what will happen? On restarting the SQL Server, it will go and check here in the transaction log whether there were any uncommitted or uh, some transactions which are not rolled back. It will go and check in the transaction log, and it will get the status saying that okay, there is one transaction which is executing at particular state, which was executing at particular statement when the when system was crashed. So here it will ask, it will find out the best situation, whether it can be continued from here or no, it cannot be continued, so it has to be rolled back. Any one thing will be done in these two. It will not leave the transaction as is. So it will make sure it is either committed or rolled back. So what we call this particular thing, I mean continuing from there, is redo. It is redoing the work. I mean continuing from the same. And if it is rollback, then we call it a system. In DBMS concepts, we call it as undo. It will undo the changes that has been done, or else it will redo. Either it will be rolled back completely and reach the start of the transaction state, or it will be committed. So this is the beauty and advantage of durability concept, and SQL Server has transaction log file to make sure that all the transactions will be either undo or redo if the system crashed in the middle of the execution of a transaction. SQL Server has a transaction management to enforce or to make sure that the transaction is atomic and consistent. Okay, SQL Server has built-in management, transaction management, to make sure of these two guys, and it has transaction log to make sure of durability property, right? So we have some management or some files or some source to make sure that the consistency and atomicity of the transactions are maintained and durability of the transaction is being maintained. So the only thing is isolation. The isolation, we have to make sure, we have to pick what kind of isolation method you want to set. There are different types of isolation methods. Before coming to that, to set the isolation, we need locking mechanism, right? So now let's see a little bit about the locking first, and then we'll go for this isolation method. What is the use of locks and how to set the locks and so on. We have so much to learn about SQL Server locks. Okay, so keep in mind we discussed about all the asset properties and how it will be handled, and for the isolation we need to revisit how to define different isolation levels of for a transaction, and how to make sure that every transaction will be isolated from the other transaction. That's the pending task. And now let's go back to the concurrency. So there is something left, which we need to discuss now, the concurrency. The concurrency, if you don't use locking, okay, and many users are trying to access the database concurrently, then problems may occur when the same data is being accessed at the same time. When the same resource is trying to access the same, when multiple resources are trying to access the same data at the same time, then I told you we may face some problems. And what are those kind of problems? Let's discuss about the problems here, and then the solution for these problems, how to avoid these concurrency problems. Okay, so there are 4 different kinds of problems provided in SQL Server, that is lost or buried updates. What is let me list out all the stuff, and the next one is, I think, uncommitted dependency. We also call it as dirty reads. And the third one is inconsistent analysis. Or we call it as non-repeatable reads, and fourth one is phantom reads. So don't think that these are the properties of SQL Server. These are the problems we are going to face if concurrency is in picture and no security measures has been taken care. So when 2 to 3 resources are trying to access the same data at the same time, the chances of occurring these errors are pretty high. Now let's discuss about each and everything first. Then you will get a clear picture why it is having and why it is leading to these kind of problems. First, lost or buried updates. These are the problems of concurrency, of having concurrent reads or updates. So the first one is lost or buried updates. Generally, these lost updates occur when two or more transactions select the same row and then update the row based on the value um, originally selected. For example, if I have two guys updating a same record, let's say, let me take one table name, select star from dim product, where product key is equal to 101. I don't know whether it is available or not. Let's see. Yeah, it is available. Now, two guys, user 1 has written this query, update dim product set, I'll take English product name is equal to, I'll give new name, test 1, where product key is equal to 101. And there is one more user executing different query, and he is modifying the value with test 1, 2, 3. So this is part of one transaction, DGIN transaction, and no transactions at this point of time. Let's say the first query is being executed by user 1 who sits in USA, and the second query is being executed by user 2 who sits in some other place or in the same place. The place doesn't matter here. I'm just telling you an example that people are not aware of executing the same kind of query on the same record. So when the first user executes this and the second user executes, both sends the query which reaches the server late, that is second, the change will be permanent. For example, first let's say this query reached the server and executed. So this guy's name, English product name will be updated to test 1. And immediately within fraction of seconds, if this query hit the same database, and the value will be changed to test 1, 2, 3. So the problem here is the first change will be overwritten with the other guy's change. And once he executed, the first user executed, and after that he tries to select the data, and if he sees that the value is changed to test 1, 2, 3 instead of test 1, that means he is not reading the exact data that he is looking for or that he is updated. So the lost or buried update means the first update is getting lost or buried, right? So this scenario is called as lost updates. The first update is getting buried because of the second update query is executed. So this can be taken care by applying logs properly to the transactions. So this is about lost or buried updates. Is it clear, guys? Okay. So next, the second one is uncommitted dependency. So before the data or dirty reads, so when one guy is executing the transaction, okay, and if you don't apply the log, so let's say I have a begin transaction and I have some statements and commit transaction. And if I don't apply the log, if I don't apply the proper locking mechanism or isolation methods for this, then when this particular statement, after this particular statement is executed, okay, and if some other user executes a select statement, select star from table name, then the data that will be read is on the state data, whatever the state of the data that is present, whatever the updates that is done by the user 1. And if anything goes wrong in the next statement and if it reverts back, so the data will be different and the data what is showing to him is different, right? So that means before the data is committed, when the or confirmed or finalized, when the other user reads the data, then it will have uncommitted reads or uncommitted dependency or dirty reads. It is not going to give you the correct data. It should be in committed position, right? The data should be committed. Now I have 100 statements. I started executing a transaction. After executing 50 statements, if another guy access the data, he will get 50 records. I'm inserting 100 records, let's say, into a table, freshly created table. After executing 50 records, if the second user executes a select statement on that, he will get 50 records. And if there is any problem and everything is rolled back, then, or if I make some changes to the data by using update statements in the next select statement, next TSQL statements in the transaction, then the problem is the data that is present in the guide that is present in the result set of the user 2 is not the correct one that is present in the database. So if you don't have proper isolation or locking mechanism here, then it will lead to read dirty data, the data that is not present in the database, but still it will show in the result set. We call this concept, this kind of errors, as dirty reads or uncommitted dependent. Now let's see the third one. The inconsistent analysis or non-repeatable reads. So what it means is, let's say I have a simple select statement, begin tran, and I'm inserting into a table or updating a table, update dim product set English product name is equal to something where product key is equal to 101. Let's say I'm executing this query and commit transaction. So when I see this inconsistent analysis will have more than one reads, or we call it as multiple reads. So I have a couple of select statements. Select star from dim product where product key is equal to 101. And let's say I have two select statements which is executing the having the same where condition on the same table. So when the transaction is executing, when the transaction is currently in process or progress, then if I execute the same statement multiple times, okay, the first read will give me different value and the second read will give me different value, right? This is because I'm not making it as isolated one. If I make it as isolated, it won't take the updated value. Both the queries will return the same value. So the inconsistent analysis or non-repeatable read says that when multiple select statements are applied on a particular row of data which is being modified by other transaction, it will give different results in different times. Let's say I'm executing some 100 statements like this, okay, for different IDs, 101, 102, 103, 104, 105, and so on. And I'm reading the data using select statement without any gap, without giving any gap. I'm continuously executing these select statements for, let's assume. Then every time when I execute this select statement, the result set will be a different one. So in this case, these transactions will take very less time. That's why you are not getting clear picture about it. When the transaction takes hell of time, some transactions will take hell of times, like updating some millions of records. When updating millions of records are going on for every select statement, which will, the updating of millions of records will take a lot of time. So in that gap, if the transaction is not isolated or proper logs are provided, and if it is concurrent, if concurrency means one side it is accessing the same resource and another side it is updating the same resource. When the concurrency is in picture, then it will lead to inconsistent analysis, which means it reads different data every time it executes the select statement. So this can be avoided by using locking mechanism. if you observe all these things, these are very related, very close, and at the end the concept is the data will be different in the source and the data that we're reading will be different. That's the only concept, but with slight differences they are adding many things, like one, dirty reads, and dirty reads, it says that the data will be different in the source and the data what we're fetching is different in the using the select statement. It's just because either rollback or it is not committed properly and so on. But here if you see, this is also the concept wise it is same. It is going to read the dirty data. It is that the data is inconsistent between two select statements or two reads. So, and if you see the phantom reads, it is also a similar one. Let's say this happens just because of insert or delete. Okay, insert or delete. Let's say I executed two select statements again when the transaction is inserting the data on the other end. That means the first read will not give me the record. The second read will give me the record. Right? This is inconsistent. So we call these kind of things as phantom reads. And in the same way, delete. If you execute two reads and the first read will have the record and the second read will not have the record. Why? Because it is deleted by some other transaction. So this kind of issue is called as phantom reads, and you can apply some locking mechanism so that it will make sure that both the reads will give you the consistent data. So I mean, if you observe all these three except the first one, right, except the first one, all the three looks very similar, very close. I mean, it says or it talks about reading the dirty data or reading the data that is not present or that is already updated or that is not as is compared to the result set whatever we have read using select statement. So to avoid all these things, to avoid all these kind of dirty reads, inconsistent analysis, phantom reads and so on, generally we use, or any DBMS system uses logs. Logs is the best feature that is available to log the data, and you can hide the data, or you cannot provide the access to the resource to the other users. Let's say I have applied log to this update statement. Okay, and if I don't allow another select statement to read, then it will wait until it comes to a consistent state, right? Until all the data is updated, it will wait, and the data that is read will be the same in both the select statements. While the execution is going on, if it applies lock, then what will happen? It won't allow the another user to read the data until the lock is released. Once the lock is released, even if you execute twice, thrice, the data will be the same, right? So logs plays a major role in the pessimistic concurrency model, and it helps and while modifying the data like anything. Logs has three different aspects. Like first one is log duration and log modes. And third one is log granularity. So log duration talks about for how long it has to be set. The log needs to be set. The time period during which a resource holds the particular lock. For example, if I define a lock on a particular page or particular row or particular table, then this duration talks about how long it has to hold that particular page. Generally, it holds the page until the query is executed, and we can set the log duration differently. And it also depends on the log duration, also depends on the mode of the log we are giving. Okay, let's discuss about the mode of the logs. And log duration is just a concept or aspect of this logs which talks about the duration, how long it has to hold a particular resource, which is defined with logs. Now it's log, LOCK. Now let's see the log modes we have that are available. So log modes specifies, generally it specifies different types of logs or different kinds of logs that are available. Mode means it's a type or it's kind. It always depends on our choice. I mean, you can pick it, whatever type of log you wish to apply on a particular resource. Or if you want to lock a particular table, or if you want to lock a particular row, you can decide what kind of log you want to use on that particular statement. So there are three different types of logs that you can set at row or page level. You can set a different granularity. Granularity means setting at different levels, page, row, table, and database level logs. You can set a different granularity. So at the page level or at row level, you can set three different kinds of logs. One is shared log, next one is exclusive log, and the third one is update log. So we call it the short form of this one is shared, the short form of this one is capital X exclusive, and short form of this one is update logs. So log modes talks about what are the different types of logs that are available and you can use, and log modes again depends on granularity. If you want to set the log on a particular row, then you can go for page or rows, then you can go for three types of logs. One is a shared log, and another one is exclusive log, and the third one is update log. So if you see the shared log here, it acts like a as the name says, it's a shared one. So if it wants to read the data, it will apply a shared log on it. Okay. If it wants to read the data, it will apply a shared log on it. For example, select star from a table name where employee ID is equal to 101. Here I'm trying to read the data. So I can have a shared log on the data that on the select statement that I'm using to read the data. The shared log will make sure that once the shared log is applied on a particular resource or particular table, then another resource can set the shared log on the same. So shared log can be applied by multiple users on the same table or same resource, I can say. Let's say this is the data that is being pulled by many resources. First, this guy will apply a shared log on this, and he will start reading the data. And the other guy can apply another shared log, and read the data. And the third guy can apply another shared log and read the data. So shared log is used for reading the data from a table or from a page. So this shared logs is mainly for, it reserves a resource for reading, I can say. It reserves the resource for reading the data. When a shared log is applied on a particular resource, and other resources cannot able to update the data until the shared log is on a particular resource. So now you have a shared log on this particular resource, right? If I'm the fourth user who tries to update this data, it won't allow. It won't allow until any shared log is available on this particular resource. Next one is, let me take this picture out. Let's say I have a data or resource, I call it as. It can be the page or row. I'm calling it as resource. Now, if I apply an exclusive log, if I apply an exclusive log, then no other log can be applied on this by any other resource. Let's say user 2 is trying for shared log, it will say not possible. Man, you can't have a shared log here. If another user try to have an update log, it will not allow. If another user try to have a exclusive log again, another exclusive log, it will not allow. So the only thing that will, once the exclusive log is set, then no other log can be set on the particular resource until this exclusive log is removed. So where we can use this exclusive log? Obviously, it is for DML statements like updating the data, deleting the data. So whenever you're doing such kind of DML statements, then you can make sure that you set the exclusive log on the particular resource that you are modifying. So exclusive log is nothing but the log that is used for DML executions, and once the exclusive log is set on a particular resource, then you cannot set any other log either to read the data or to modify the data. Now, about the third one, that is update logs, it acts like hybrid of both. So if I have an update log on this, if any user is having an update log on this, the another user can have shared log, but the another user cannot have exclusive log on this. So the update logs acts in such a way that if you set an update log and if it is updating the queries, or if it is modifying the queries, or if it is deleting the data, then it will act as exclusive log, and it will make sure that shared lock is removed, and then it will become exclusive. And if the shared lock is present, it will be acting as shared lock. So I'll tell you a best example. Let's say I set an shared lock. It is reading the data, and sorry, let me take a new picture. So let me take it here. So I have a resource. I set an update log, and it started reading data. It is reading some records from the resource. In that case, I can have one more shared log to read the data. No issues. It won't create any problem. And I can have one more record here. One more user can set one more shared log to read the data. But when the time comes to update some data using this update log, or delete some data using this update log, then it will wait until these two gets closed. Okay, once these two gets closed after doing their job, the logs will be released, right? When these two logs are released, then this guy will become as exclusive log, and it won't allow any share log after this when it is updating the data. So the update log acts as share log when it is reading data, and it acts as exclusive log when it is updating or modifying the data. So now let's see the compatibility. We need to know, right, how each log is compatible with the other one. Let's say the shared one. Next one is exclusive, and the third one is let's go with this one here, and shared, update, and exclusive. Shared log can have when it is a shared log. I'm trying to write a table here, man. I don't know whether I can make it here. Update and exclusive. Okay. Shared log can be set when another shared log is available. True. And shared log can be set when another update log is when another resource set an update log. Yes, you can set. Shared log can be set when exclusive log is there. No, we cannot set that. Now, when update log is there, you can have a shared log. Yes, we can set it. Sorry. Yes. What the fuck? Okay. And update log cannot be set when another resource, when another user set an update log. You cannot set this. It is not compatible. And when it is an exclusive, you cannot set an update log. And the third case, exclusive, all the cases will be no. No, no, no. So if you see this table, when a shared log is there in a resource, you can set another shared log. Fine, it is possible. When a shared log is there, you can set another update log. It is fine. When a shared log is there, another exclusive log is not possible. And in the same way, when the update log is there, you can set one shared log. That is the reverse process of this. Okay, this is fine. When the update log is there, sorry, this is no. You cannot set another update log. You are not supposed to set, and you cannot set. Why? Because an update log acts as an exclusive when it is updating the data. So that is not possible to set an update log. And exclusive log you cannot set. And for exclusive log you cannot set, once the exclusive log is set for any resource, then you cannot set any other log on the same resource. So this is the three different comparison sheet for the three. Now we have discussed about different log levels at row or page level. Now let's see the table level locks. We can set different level of different types of locks at table level. First, let me list out those locks what we can set. The first one is a shared, and the second one is exclusive. We already discussed about these two things. And the third one is intent shared, intent exclusive, shared with intent exclusive. So these are all the different types of locks you can set at a table level. And you are very well familiar with what is meant by shared and exclusive locks, right? It is same like what we discussed in row level or page level locking types, locking modes. Okay. Now the intent lock, if you can understand the intent lock, then if you see everything will be an intent here. That's it, an intent, extra intent for either shared or exclusive locks. Generally, an intent lock shows an intention to lock the next lower resource in the hierarchy of the database object. For example, if I set a lock at table level, it won't show, intent lock at table level. I'm highlighting intent lock at table level. It won't set the lock to the table. What it will do is it will do the locking at next level. What is the next level of table? It is data, right? So it won't set. That is called intent lock. Even though you are setting the lock at table level, it will be treated as the lock at the whole data that is present in the particular table. These intent locks will be applied always to the next lower resource in the hierarchy. So what is the, if I set the lock at database level, then the intent lock will be set to, sorry, let me repeat. If I set intent lock at database level, then the intent lock actually will be applied to the next lower level, that is table, stored procedures, and so on. In the same way, if you set an intent lock at the table level, then the lock will be applied to the next level in the hierarchy, that is the data in the table. So always whenever you are trying to go for intent locks, then you have to make sure that you are placing the lock at one level above to the desired resource. For example, if you want to set the intent lock to the rows in the table, then what you have to do, you have to set it to the table. Then the lock will be applied to the rows. So keep in mind, intent lock always set the locking mechanism to to the next level that is present in the hierarchy, and that is why you have to be very careful. If you decided to set the lock for a particular table rows, then you are not supposed to set the lock for at row level. You have to set the intent lock at table level. Then it will be applied as expected. Now the same thing, intent shared means it will become shared. Intent exclusive means it will become intent exclusive. Exclusive for the data if you apply for a table. And shared with intent exclusive means it will have both shared as well as exclusive, but for the data if you apply for the table. Now let's see, this is the shared lock and this is the exclusive lock. This is the intent shared and this is the shared intent exclusive and this is the intent exclusive. Now let's see how these guys are compatible. I'm taking the same here, S, X, IS, SIX, and this is not mandatory for interview purpose, but it's always better to keep in mind. Shared can be set on shared, fine. Exclusive and shared, it is no, that is N. And intent shared and shared can be set, that is yes. And shared intent exclusive and this one no, and this one no. And you know exclusive lock cannot be set with anything, so no for everything. And now intent shared can be set with shared one, and with exclusive no, with intent shared yes, shared intent exclusive yes, and intent exclusive it will be no. And shared intent, this one exclusive, it's a no, no for exclusive, and yes for intent shared, no for this, and intent exclusive it is yes. Sorry. So this is how you can have a chart which says that for what all logs it is compatible. If I have a shared log, whether I can have a intent shared on the same resource or not. You can get a clear picture if you have a table like this. So just try to keep in mind, if not, this is not of high priority, but better. Intent exclusive to exclusive, no. Intent exclusive to share, intent shared, it is yes, and this is no, and this is yes. This is the table what we have for sorry, this guy is no man. Okay, this is about the compatibility of any two logs that are present at table level. So the difference between row level locking and table level locking is the only thing is intent, the intended type of logs, which means that applying the locking at next level in the hierarchy. So that means if you apply that lock at table level, the lock will be taken into sorry, the lock will be considered rows level or data level, I can say. Now this is about the different types of locks or data, lock modes we have discussed, and the next thing is lock granularity. So we have a lock granularity and some other concepts like deadlocks. So let's see all these things with examples in the next session, and also we discussed about isolation levels in the next session. Thank you guys.